folks. I hope you enjoyed that intro as much as I did. It's definitely fantastic. We are anticipating a complex meteorological scenario characterized by a challenging ejection phase, notably influenced by a substantial subtropical linkage. We can see that here. It's definitely going to be pretty intense. This scenario is orchestrated by a primary driver system originally forecasted to descend from the Pacific Northwest. You can see that system right here. It was tasked with the assimilation of a precursor system positioned proximal to the California coastline. So this system here, so these two were actually supposed to assimilate. But unfortunately, it looks like subsequent analysis revealed the trailing perturbation within the southern atmospheric stream exhibit diminished intensity compared to initial model projections approximately 4 or 5 days ago. This discrepancy highlights the cruciality of the trough configuration in atmospheric analysis. So we're going to delve into this. It's definitely be a pretty interesting video. Definitely stay tuned. As we approach Tuesday evening around 6 p.m., it's definitely noteworthy that the main trough axis remains significantly positioned near the Four Corners region. We can see that here. Definitely looks like the trough axis is right in here. Our focus will definitely extend over towards Illinois at this time period. This is going to be situated well ahead of the trough's influence. Typically, such a spatial arrangement does not align with the conventional prerequisites for extensive severe weather phenomenon. However, it is crucial to consider the potential for ageostrophic circulations to develop along the northern periphery of the enhanced wind field. These circulations could introduce localized lifting mechanisms conducive to convective initiations. We're going to have to watch this very carefully in this area. We could have some of those ageostrophic circulations forming here. This analysis is predicted on outputs from the North American Mesoscale or the NAM forecast model. The term ageostrophic refers to wind components deviating from the geostrophic balance, which is the equilibrium between the Coriolis force and the pressure gradient force in the atmosphere's horizontal plane. Such deviations can lead to ascending air motions, thereby facilitating cloud and potentially thunderstorm development under conducive conditions. While this overarching setup may not traditionally favor significant severe weather development, the nuanced interplay of atmospheric dynamics, particularly the ageostrophic circulations mentioned before, adjacent to stronger wind zones, warrants meticulous monitoring for localized severe weather potential within the specified region and time frame. So we're definitely looking at Illinois, Indiana. Upon examination of the global forecast system or the GFS model, notable discrepancies persist in model outputs, with the GFS indicating a marginally accelerated progression of the primary dynamic system termed the kicker system. Notably, this system appears to temporally displace a segment of vorticity toward the Southern California vicinity. Concurrently, we observe an extensive zone of subtropical connectivity characterized by its elongated configuration. Within the domain of this subtropical interaction, the presence of pronounced bulk shear is anticipated. Bulk shear, defined as the change in wind speed and or direction with height within the atmosphere, is a critical parameter in the assessment of storm dynamics, particularly in the context of thunderstorm intensity and organization. While the presence of bulk shear under the subtropical axis is noteworthy, the genesis of tornadoes dictates the presence of substantial low-level wind shear, which encompasses the vertical variation in wind velocity near the surface. A brief analysis reveals a marginal influence of a west-southwesterly low-level jet with velocities approaching 40 knots. You can see 39 knots there, 36 knots there, impinging upon the central Illinois region. Turning our attention to moisture parameters, specifically dew points, the initiation of severe weather conditions typically requires dew points reaching or exceeding 60 degrees Fahrenheit. In this instance, a projection of 60-degree dew points extends into central Illinois, suggesting a conducive moisture environment for severe weather phenomena to develop. This meteorological setup indicates a somewhat progressive upper-level system trailing the moisture axis, thereby orienting the moisture influx towards central Illinois. The North American Mesoscale model, or the NAM model, extends this moisture projection into the northwestern Illinois sector, thus encompassing the Davenport area within the realm of potential severe weather influence. In the broader context of global model analysis, the expansive slight risk area delineated suggests a consensus towards potential severe weather activity. However, the NAM model presents as a deviation from the consensus, prompting a reliance on the operational GFS model for immediate forecasting purposes. particularly in delineating the moisture axis trajectory, potentially extending toward Effingham, Illinois. So we're going to have to watch this carefully. Let's switch over to the GFS model. Near Chicago, the moderating influence of Lake Michigan, particularly notable during this period due to its significantly reduced temperatures, is expected to introduce surface temperatures into the 40s by 6 p.m., with a gradual increase observed as one moves away from the lake's immediate influence. This thermal profile indicates a predominance of stable air conditions proximal to the noticeably cold Lake Michigan, with the moisture axis extending nearly to Champaign, Illinois. So we're going to have to watch that very, very carefully. Despite the lagging trough position substantially westward in the Four Corners region, the existing atmospheric setup, characterized by sufficient moisture and lifting mechanisms, may still harbor the potential for tornado genesis, underscoring the complexity and nuanced nature of atmospheric dynamics in severe weather forecasting. A modest surface cyclone is forecast to traverse western Illinois, which is anticipated to induce a slight veering of the surface winds towards a more south-southwesterly orientation. In the vicinity south of this boundary, an intensification of southerly winds is expected. Consequently, it is projected that a zone of prefrontal confluence bands will materialize along the northwest periphery, so right up here. It's definitely be interesting. It's definitely projected that a zone of prefrontal confluence bands will be in this area. This is definitely going to serve as a catalyst for convective initiation. It is plausible that the onset of storm development could be slightly delayed. However, the presence of a more vigorous southerly airflow to the northwest margin of this moisture concentration is anticipated to be the principal region for storm genesis, with a temporal window between 4 p.m. and 6 p.m. This scenario suggests that the severe weather phenomenon will predominantly manifest during the evening hours. Additionally, a surface low with central pressure near 991 millibars is also forecast with this system. A comparative analysis with the North American Mesoscale model, or the NAM model, indicates a less pronounced surface low, accompanied by moderately lower dew point temperatures, which are indicative of lesser moisture content in the atmosphere as per the NAM's output. This assessment is based on the 6 p.m. forecast cycle. Within this atmospheric setup, a reservoir of dew points in the upper 50s, possibly 60s here, is observed, extending the potential severe weather threat into regions such as southeast Iowa. This disparity in model outputs underscores the inherent uncertainties within numerical weather prediction, imposing a cautious approach in interpreting forecast data, particularly in the context of severe weather preparedness and response strategy. So we can see here we do have that pool of 60 and 61 degree dew points here. This is possibly extending into extreme portions of southeastern Iowa, northeastern Missouri as well, and even into western Illinois here. So we're going to have to watch this. We're going to carefully monitor this. Definitely we'll see what these 60 degree dew points do as the time frame of the storms approaches near. Upon detailed examination of the 3-kilometer resolution North American model, the NAM model, with a forecasting horizon approximately about 41 hours out, we observed the atmospheric conditions during the early morning hours around 6 a.m. Initial assessments indicate that the model does not project an environment conducive to severe weather development at this stage. So that's definitely interesting. We do have upper 50s dew points, but we need those 60s to start to nose in here. You can see they are starting to nose in into the southern Illinois. But let's take a look at 4 p.m. So we're going to have to go to 20Z here. And there we go. We can definitely see we have that observable cluster of moisture with development, with dew points reaching into the 60 degrees Fahrenheit. This is extending from, you can definitely see, this is definitely going to extend from eastern Missouri into west central Illinois. However, it's definitely important to note that the NAM model predicts a mixing out of these higher dew points, precluding the presence of 60 degree dew points within this region. But we can see there's definitely a window here that could possibly be conducive for severe weather development here. So we're going to have to watch this very carefully. This model does forecast a slightly stronger surface low, which is a significant feature in the context. When analyzing the Energy Helicity Index, or the EHI, within the 0 to 1 kilometer layer, we find an overlay of low-level wind shear with surface-based instability indicative of a potentially favorable environment for severe weather development in west central Illinois. This is further confirmed by sounding data, which reveals substantial directional shear with relatively weak surface winds. We can see that it's about 15 knots at the surface. The hodograph depicted in the upper right section here of the sounding is instrumental in this analysis. Ideal hodographs for severe weather, particularly tornadoes, exhibit a pronounced hockey stick shape indicative of significant directional wind shear. The curvature observed in this case, along with the storm motion vector oriented almost due east, attributed to the prevailing southwesterly mid and upper level winds, suggests a conducive environment for severe convective development. The length of this storm relative inflow vectors extending from the tip of the storm motion vector here back to the hodograph axis is actually notably long, implying substantial storm relative inflow at lower levels, which is critical for sustaining severe storms. Furthermore, the presence of an elevated mixed layer, or EML, so we can see that here, propelled by strong westerly winds extending from the Mexican Plateau across the agricultural heartland of the United States, or the Corn Belt, introduces dry air aloft as evidenced by the divergence between the dew point and the temperature lines. You can see that here. You can see the temperature line, a little bit of a divergence there. This EML, despite being associated with newly arrived moisture and the aforementioned discrepancies in timing, contributes to the deep moisture content observed in the forecast sounding. So we do have some deep layer moisture there. So that's definitely a good sign. Directional shear at lower levels is particularly pronounced as well. This is transitioning from southerly surface winds at 1 kilometer, reaching velocities of, let's see here, about 35 knots, and further intensifying to strong southwesterly winds here. So 1 kilometer above, we're looking at about, let's see, 10, 20, 30, about 35 knots. 700 millibar here, we're looking at about 55 knots. So this shear profile is conducive to the formation of curved hodographs, which are indicative of a dynamically favorable setup for severe weather, despite the velocities at 1 kilometer not surpassing 40 knots, which is below the typical threshold for a strong low-level jet. A more potent low-level jet would be about 45-50 knots, coupled with the proximal ejecting trough. That would definitely enhance the temperature gradient across the region, thereby intensifying the low-level jet and amplifying the potential for severe weather phenomena. The NAM model delineates a notably subtle low-level jet stream within the axis of instability over central Illinois. In comparison to the GFS model, despite this, the model forecasts the presence of vigorous westerlies reaching velocities between 50 and 60 knots. Critically, for the enhancement of severe weather potential, particularly in the context of tornado genesis, the presence of a southwesterly wind component at 1 kilometer altitude along the northwestern fringe of the low-level jet over western Illinois is definitely imperative. And if we head into, let's go to 23Z here, definitely we're going to have an advancement of a 50-knot low-level jet converging directly upon the budding supercells here. So you can see one supercell here in northeastern Missouri here. This convergence zone is of particular meteorological interest as is accompanied by slight veering of the low-level jet, yielding a more southwesterly orientation at the northwestern boundary here of the low pressure system here. Concurrently, discernible gaps within the wind field may signify the embryonic stages of storm development anticipated for Tuesday afternoon and evening. So let me go back here. Let me just show you guys some stuff that we got. Some data that is actually pretty neat. There we go. So if we look at EHI, we could look at storm. Okay, there we go. If we look at SRH here value, storm relative helicity, you can see these holes here. So one there, one here, one here. These are actually embryonic stages of storm development. So it's definitely pretty interesting to see here. So we're definitely going to be looking at that. The storm cells depicted within the 3-kilometer NAM model exhibit characteristics conducive to tornado formation, notably influenced by the incorporation of a 50-knot southwesterly low-level jet. So we can take a look at that. Yeah, it's definitely going to be rampant here, guys. So 50 knots. It's definitely pretty good. An analysis of forecast soundings along the southeastern edge of this convective activity reveals a overworked sounding. So let's take a look at that. Let me pull one up here. Let's go to Let's take a look at the composite radar here. There we go. Let's go to here. So yeah, you can see this is kind of an overworked sounding here. Let's get a better look at the sounding. There we go. It's a little bit overworked. So let's actually take a look at one that's just a little bit better. Let's move off a little bit further east. There we go. That's a better one there. That's definitely pretty good. So the forecast sounding indicates relatively cool surface temperature. So, I mean, 63 is still pretty good. Unfortunately, the convective temperature is at 69 degrees Fahrenheit. This threshold delineates the minimum surface temperature required to overcome atmospheric capping and foster surface-based convection development. This scenario underscores the critical role of the low-level thermodynamics in severe weather potential, particularly in the context of tapping into the pronounced directional shear prevalent within the low levels of the atmosphere. You can see that directional shear right here. It's definitely pronounced. Unfortunately, or frequently, this considerable directional shear is juxtaposed with a shallow, stable atmospheric layer near the surface, which can temper the convective potential despite adequate moisture availability. The proximity to, yet slight removal from, the convective temperature threshold emphasizes the nuanced balance between surface heating and atmospheric stability in dictating the scope and intensity of storm-based development. All right, so as we transition towards the evening, let's say about 8 p.m. here, conditions are conducive to the formation of a nocturnal inversion, a phenomenon characterized by a temperature increase with altitude contrary to the typical daytime pattern. This inversion can act as a cap inhibiting convective activity. Observations suggest that the convective systems across northern Illinois are marginally engaging with the available surface-based instability. We definitely have to watch these cells. It is imperative to acknowledge the discrepancies presented by the 3-kilometer NAM model, which predicts a delayed propagation of the atmospheric wave. This delay influences the spatial and temporal distribution of instability, particularly noted in the west central Illinois region. If we take a look at the GFS around this time as well, you can see that the storms are basically moved on into eastern Illinois and into western Indiana here. So it definitely looks like there's going to be sort of a delay there. So it's definitely a discrepancy. It's definitely not good. And definitely, given these uncertainties, it may be prudent to await the high-resolution rapid refresh or the HRRR model's forthcoming analysis for a more refined understanding of the evolving weather scenario. The axis of instability delineated by dew points in the 60s extending into central Illinois. Let's pull these up. See that right there. You can definitely see those nodes of dew points coming in. This is extending into central Illinois is largely a result of distinct evolution of the trough configuration within the atmospheric setup. So the presence of tandem troughs, as currently observed, frequently precipitates model discrepancies due to the complex interactions between these features. These regions extending from Champaign towards Effingham and potentially just south of Chicago here appear to be prime for conducive convective development, particularly in the late afternoon hours. So we can see right around 21Z. Let's actually go back to the 3-kilometer NAM here so we can get that going. Show that on here. As you can see those prefrontal confluence bands as well. This is right around 21Z. This is around 4 p.m. and then 22Z around 5 p.m. It looks like, and then 6 p.m., 7 p.m., and 8 p.m. definitely look like to be prime time hours for severe weather here. So it's definitely interesting to see what's going on. We definitely want to keep you guys informed. But some of these soundings are definitely pretty interesting. You can see that curvature, the low-level curvature, 0 to 1 kilometer shear there, 276 meters squared per second squared. Storm relative helicity. Looks like 54 degrees for the critical angle. We're looking at we need 90 degrees there. Closer to 90 degrees would definitely allow for more tornado genesis to occur. That's because the storms ingest streamwise vorticity instead of crosswise vorticity. Cape values are perfect, though. 1,695 joules per kilogram. That is a lot of Cape. Downdraft Cape is at 952, so we're definitely going to see some strong winds. So it definitely looks like hail, strong winds, flash flooding, lightning, and damaging winds. Damaging winds and hail are going to be most likely the primary threats of this storm. We're definitely going to see a few isolated tornadoes, unfortunately. So if you live in southeastern Iowa, up through northwestern Missouri, all across Illinois. Let's take this all the way out, even into portions of southern Wisconsin. Let's take a look at that. There could be the possibility of tornadoes forming there, especially with that hockey stick shaped hodograph there. Critical angle is near 74, so definitely nearing 90 degrees. So more streamwise vorticity will be ingested by these storms up to the north. We're going to have to watch those carefully. Even heading into towards the Chicago area, we have omega values coming in. We're definitely going to see some rising air there, and definitely some downdrafts as well. 495 for the D Cape, probably about 45 mile per hour winds there. So that's definitely very interesting. We can see this is sort of delving into a QLCS, or a quasi-linear convective system, or a squall line. So this is actually by 2Z. So this is right around 9 p.m. As we head into 10 p.m., looks like Chicago definitely gets steamrolled by one of these cells. Definitely a lot of wind is definitely be coming into the Chicago area. Definitely the potential for a few tornado watches and warnings to go up. Maybe a brief spin up, possibly a water spout going across the lake there. We're going to have to watch that. The southern tip of Lake Michigan, between the interface of Illinois and Indiana, we're going to have to watch for the potential for water spouts. As we head further south, definitely looks like the severe weather activity is definitely waning there. Looks like we have a cap of 133 joules per kilogram. So it definitely looks like it's going to be more of a central Illinois to northern Illinois event. And then eventually it's going to transition into Indiana as well. Definitely looks more of a severe mode there. We could definitely see brief spin-ups, especially with those 408 meters squared per second squared. SRH values, the sounding does look a bit overworked. Unfortunately, if we head up towards northern Indiana, it's right around the same thing, a little bit of overworked sounding, but definitely be on the lookout for tornadoes. It's certainly possible. And as we head into 5Z, this is right around midnight. Looks like those storms enter Michigan as well, southern Michigan, right through the Grand Rapids area, down to the south as well, towards the Indiana border. Grand Rapids definitely looks like marginal severe. We could definitely see some lightning. We have a good ventilation rate on some of these storms as well. It's definitely photogenic tornadoes if they do develop. It'll definitely be pretty interesting. Unfortunately, this is going to be a nocturnal event, so the only visibility of these tornadoes you're going to get, if any of these tornadoes do form, we're probably going to see them during lightning flashes and unfortunately during power flashes as well, so it's not going to be good. And then into 1 a.m., it does look like the severe weather is starting to die down a little bit, even into central Michigan here. Could be marginal severe weather, 53 degrees for the temperature. It's a little low, but nevertheless, definitely be on the lookout for that. And I extend my gratitude to all who have participated in this weather briefing. From the World Weather Authority studio, we remain committed to providing comprehensive and authoritative meteorological insights, empowering you to effectively anticipate and navigate the complexities of severe weather phenomenon. And always remember, folks, dominate the storm.
World of Weather with World Weather Authority, your #1 source for all things meteorological. Covering every corner of the globe, we're dedicated to delivering you the most accurate, timely, and comprehensive forecasts, ensuring you're always prepared, whatever the weather. Our experienced team of meteorologists are at the forefront of weather technology, tracking patterns from the serene to the extreme. Here at World Weather Authority, we go beyond the forecast, delving into the science behind the weather and its impact on our environment, our lives, and our future. Our commitment to accuracy and insight has built a community of viewers who trust us for their weather news, fascinating facts, and crucial updates. So why not join us? Don't miss a forecast. Subscribe, hit that bell icon for notifications, and follow us on social media. Stay ahead of the weather, no matter where you are, no matter the season. This is World Weather Authority, where the weather is always the news.